Okay, it is 1 p.m. I have started recording the class. As usual, at the end of the class, I will upload a video to Canvas. Like I will upload the link. Okay. So today what we are going to do, we are going to learn 100 data analysis, data mining, and data visualization problem by using R. If you understand all of these things, your programming level, coding level in R will jump from beginner to intermediate level. Do you understand what I said? Okay. So now what I do, I went there, open the R. Let's go there, open R. Here is my R. I open the R and then I go there, open a script. And in order to open a script that I already uploaded in Canvas, I have to go there and week 2 to 4. Today is the third week. So this is my R code. Okay. And then what I will do, Windows style vertically. Let me see my data is in there. Yes, data is in there. Exam stuffs. So the covariance, I said covariance could be positive or negative, but covariance can also be 0. Okay. Okay. So what I did, I opened it. You are able to see it, right?
I just saw the grade.
You saw the grade. The question, cannot you see?
No, we can't do the question.
Okay. So here's the thing. Can I finish the class and then start discussing? That's fine, right? So let me finish the class because today's 2 hours 45 minutes is very tight because 100 data analysis and data mining problems are going to discuss. Understand? Time is very tight today. So I therefore want to finish these things and want to record this as beautifully as possible so that once it is uploaded, everyone will get benefited. Okay? Ready, right? So here I want to first declare my working directory. This is my working directory. So and then let me open this document, class practice document. This is the class practice document. In these documents, you will have all the 100 problems. So what we are going to do, we are going to use a longitudinal data. This data is simulated. Okay. This data has these variables. A longitudinal data name, class practice data CSV simulated with the following variables: identification number, race, income, age, smoke, systolic blood pressure, diastolic blood pressure, height, weight, waist measurement, body mass index, visit number, sugar, measurement of the chest, hips, arms, and total cholesterol, triglyceride, high density lipoprotein, low density lipoprotein, pulse rate, waist, category, number of login in the electronic device, time spent on the device, event. These are the variables. So what do we want to do first? Set up working directory to import the data. So if you go there, the first line of code, this is what this is called set working directory. Okay, are you seeing SCT, set WD working directory? So my working directory is user, desktop, all ASM, fall 225, DPS 623, F, face-to-face folder. This is the folder where I am keeping all the materials. Okay, and then week 2 to 4, because week 2 to 4 I am going to discuss data analysis, data mining, and data visualization. Do you understand? So this is the folder. Okay, this is the location where all my code and data, all the materials are saved. Okay, everyone understand, right? Are you okay? Clear? I need some happy face. Looks like you are angry. Okay, so that has been declared. After declaring these things, now I want to import the data. How I can import. This is the data. That data I also uploaded in there. So data has been imported. Okay. So because this data is sitting on that directory. Understand? Understand? Okay. So let me show you. This is the directory. All ASM, this is the directory. Okay. And this is the fall 2025. This is the face-to-face. In this case, with 2 to 4, all things has been saved in there. So I go there, I take the directory like this way, properties, and then copy these things and paste it in this line, in this line. Okay, now it has been my working directory. So how do you know what problem is what problem? You will have to go there. You have to read this document. Set up, declare working directory to import data in R or Python. First question, right? This is the first question. I will go over this Word document with all 100 problems written in there, and the R code is giving you the solutions of each of these problems. Understand? Now, are you okay? Okay. Okay. If you still struggle, have an appointment with me. I will give you virtual office hour. Or if you want me to see face to face, I can give you face to face office hour. Okay. So I have done question number 1 and question number 2. So the data has been imported. This is the question number 2. Okay, question number 2, read the CSV data. After reading the data, this is the alternative approach. Question number 3, without declaring working directory and importing the data, how can I directly import the data? What you can do directly import, you will keep this location as it is. At the end of this, you will just declare the, take a look at that. They are same. Are you seeing they are same? Except at the end, I just up until here, everything is okay. With these directory declarations and this up until here is exactly fine. At the end, I just write the name of the data. This is the direct way to import data in R. Understand? So question number 3 is asking you, without declaring directory, see, without declaring working directory, import class practice data to R and Python. Clear? Okay, after importing this, now question number 4 is asking you, check the number of observations and variables of the data. That means in that data, how many rows and how many columns. If I write here DIM and control R, then that means DIM means dimension. Understand? Dimension, I am showing you there are 20,900 rows and 25 columns. DIM means dimension, okay? So DIM means dimension. That means the data set has how many observations. That means how many rows and how many columns. Columns means variables. So data D1 has 20,900 rows and 25 columns, variables. Okay. After that, I want to know the name of the variables, which is question number 5, which if I run names, if I just run the names, we will get all the names of the variable. Take a look. Okay. What we are getting in here, we are getting all the names of the variable. Okay. All the names of the variables we are getting. Are you seeing that? So I just write what names. Question number 5. Then question number 6, I want to know the types of the variable, whether they are continuous, they are integer, they are qualitative attributes, something like that. That could be known by the R code structure. STR, you are saying STR question number 6. If I run it STR, then they will give you structure of the data. So first variable ID is integer, race is integer, income is an integer, age is a numeric. Okay, age is a numeric variable. That means it has fractional values. Okay. Similarly, there are few other numerical values like sugar and BMI, waste minimum. These are. So structure stands for the types of the variable, whether the variables are integer variable or numeric variable. Okay, are you understanding? Which one you are not understanding?
I can't get it to change.
Okay, so let me spend 1 minute quickly for you. So these things you have to change. Did you save all of your data in here? Save working there. So let me see if it is there. Command enter. It is not working. Where is your folder? Can I take a look at your folder? Where? This folder is download folder. Where is the download folder? That's it right there. Here? Here download. And then this is your CSV data, right? Now you have to copy it here, open gate information. And then you have to copy this things via Control C, and then you have to come in here. You have to go there. You have to change between here. Control V, Control V. V. Paste is what? Control V? Should be. Control V. That's nice. In a double click. It's up there, double click. Control C, Command C. Command. And I need to write here. Class underscore. This. Sorry. And how this working? Thank you. So if you are struggling after the class, like after 3:45, I will help each of you, okay? But now let me go smoothly for all of these things. So as it is recording, so if you have a problem, you can overcome these things, okay? So now structure is done. After structure, then I want to go to the question number 7, which is asking, I want to take a look at the first 6 row of the data, which can be done by running the code head D1. D1 is the name of the data. If you write the head, that means first 6 rows of the data would be shown. Okay, head. And then if you want to take a look at the last 6 rows of the data, then you can run this. This is the last 6 rows of the data. Okay. This is the last 6 rows of the data. After that, now I want to do, are you seeing? Take a look at the data. Take a look at the data. In this data, the name of the variables are not alphabetically ordered. Are you seeing? ID and then race, then income. But I want them to be ordered alphabetically. That means the variable that starts with the letter A will come first. Okay. So now it is coming ID, race, and then it is going to income, age. Okay. I want them to be ordered alphabetically. In order to order that alphabetically, I have to run this code. What is the meaning of this? D1 is the data, and in this data, I order them. After the comma, all the operations that will be done, it will go for the columns. Before the comma, before this comma, if anything written in before comma, that operation will go to the rows. Understand? Understand, right? So now let me run it and see how it looks like. A1, after running this, now if you take a look at these names, now if you take a look at the head of A1, take a look, it is coming now alphabetically order, right? The name are alphabetically order, right? Are you understanding? Now I want to do it alphabetically descending order. So alphabetically descending order could be done when I write here decreasing equal to true. So now go to the next one. And then if I write here head A2, you will see it is now in decreasing order. Understand? So what you learn, if you have a lot of variables, if you run this line of code, it will be easier for you to find your variables by alphabetical order. Understand? So the problem number 8 and 9 is telling you how to order the columns by alphabetical orders. Okay. After that, now I want to arrange the data so that lowest value of the age is coming. Are you seeing the age value, right? Age I want them to be in like ascending order, smallest to largest. Entire data sets I want to do, which could be done by running the question number 10. Question number is telling you sort the D1 data by age variable so that the age variable will smallest to largest will appear. For example, if I run this Control R and then take a look at the head of A3 and then take a look head of A3 age variable, where is age? Here is age. See, 8.96, 8.96, 8.97, 8.97. Are you seeing? It is coming in a alphabetical order. Previous data, here is the age value where it was coming 9.35, 10.38, 11.28, 12, 13, 14. Then it again go up. So, but now the data is, in that case, the age was not ascending order. Okay, so this is not ascending order, but now this is the case where age variable is coming smallest to largest. If you don't believe me, if you take a look at the tail of the data, just write tail, you see the all highest value tail of the age value. Where is age? Are you seeing? This is a missing one. This is the missing one. So they put the highest value there, and after that they put all the missing values. Understand, right? If there is a data frame, how to sort that data frame by a one variable or two variable. The next one you are going to learn how to sort the data by this is the age, and here I want to sort the data by two variable, first ID and then age. Okay, so take a look at that. This one, if I run, it is sorted first by ID number and then it will go for by age. So if I write here head A4, so this is the, take a look at that. Here ID 100011, and then it is ID is coming first. This is the smallest ID, all smallest ID, and then by their age. So this is the same persons because the ID is the same. Okay. So longitudinal study means what? Repeated measurement, right? So if you appear 10 times, then your ID will be there for how many times? 10 times. And 10 times you are coming in a different ages. So that means the ID is same. ID is same, but age is different. Each person is appearing once in a year to provide his valuable information, his height, his weight, his systolic blood pressure, diastolic blood pressure, all of this. Okay. So what you have learned in here, you have learned how to sort the data frame by one variable, by two variable, by three variable, by four variable. The way you want them to sort, you have to arrange this exactly the way I wrote for the question number 11. Now, question number 12 is telling you how to arrange the data where A's will be in ascending order, but systolic blood pressure SBP in the descending order. So what does this mean? This means H should be ascending order. Among these ascending order, the SBP should be descending order, highest to lowest. Understand? That is the meaning, which could be done by the problem number 12. Which could be done by problem number 12. And now if you take a look at the data, head A5, you will see is in ascending order, but DBP, if you take a look at the DBP, is descending order. So this is a 60 and 20. And then age is different now, 70 and 43. Okay, it is a descending. Are you seeing that, right? So when you will run this code at home, please read the Word document. This is the Word document. Please read the Word document and then run the code in order to understand these things. Remember, there are 100 problems, data analysis, data mining. How many years of experience I have? I learned R programming in 2008. When I started my PhD, I first learned, come to know R. Before that, I did not know. And then I am using how many experience after PhD? Almost 15 years, 16 years. Okay, 17 years I am using almost. So that means all of the research that I have done and write the thesis, dissertation, supervise students from all of their knowledge, I put there to create that document. Previously, there was first 40 problems, 60%, and then up until last 3 days, I prepared these documents so that if you focus on that, try to understand each line of code, you do not need to go anywhere for writing your PhD dissertations or doing data analysis, working as a junior data scientist, something like that. And whatever I have, you can learn Python by just using these two documents. What document and R code? Now you will go Python code for this, Python code for this, Python code for this. You have a data, you have a R code, or just you copy the R code, paste it in the AI and ask them provide the Python code for this R code. It will be given. So you will become a master into interpreter-based language. Understand? Don't take my word lightly. Take my word seriously. Okay, and improve your proficiency. Are you understanding? Okay, so nobody can become masters without giving hard work and efforts. If you do not put efforts, you would not be able to learn. Okay, this is true for all human beings. Okay, after doing this, now I want to do what? I want to order the D1 data by age variable and then ID variable. But if any missing value could be found, that should be put at the NA dot last. I said false. NA dot last equal to true. So that means any missing value is appearing, they should appear in the front. Okay, any missing value for this row. So if I run this and then see, if I run the question number 13, and then if I write it in here head, you will see lot of NA now. A6. Are you seeing? So that means NA dot last. What is that? NA dot last equal to, I said false. So that means NA dot will appear, all NA will appear in the first. Okay. Are you seeing NA? Clear, right? NA. So because I want to see all the missing values at the first rows. And then the problem number 14, if we run, we will see all the missing values at the last. In such a cases, if I put head, you will see nothing, no missing values. Only few missing values. But if I put the tail, you will see all missing values is appearing. Are you seeing now? And you understand the difference between head and tail, right? Head means first 6 row of the data frame. Tail means last 6 row of the data frame. Okay. Okay, after that, now I want to go question number 15. I want to take data. Now take a look at that. Dimension of D1. Dimension of D1 is 20,900 rows. In this data, there is a visit variable, which is this visit variable. I want to take only the first visit, which equal to 0. Okay, which equal to 0. Okay, I want to take only the first visit. Then the data will have only first visit. This is what I want to take, only the first visit. Now take a look at the head df1. Take a look. The visit is always 0 values, right? Are you saying visit equal to 0 values? Okay, visit equal to 0 values. Okay, that means I want to take. Now take a look at the dimension of this one, which is 2379. If I put here df1 and see 2379. Okay, so these people has only 0 visit. 0 visit means first visit. Baseline. Baselines means 0. Okay, so the people are coming for giving their blood pressure, cholesterol, triglyceride, HDL, LDL, and all of these things will be taken from a blood sample. Okay, so how that is treated? First visit is known as the baseline visit, so that is why they put it as a 0. And rest of the visit, second visit, third visit, sometimes they avoid 1. Rest of the visit they put 2, 3, 4, like that. This is the last visit. Okay, this is the last visit. So if you take a look at the last visit, how many data set is in there? That should have 2082 rows. Okay, 2082 rows. This is the last visit. After doing that, now I want to do question number 18. Question number 18, I want to subset the original D1 data by 0 visit, that means baseline visit, and race equal to 1 and income equal to 9. Understand? Income equal to 9. Income has a 9 category, 1, 2, 3 up to 9. I want to create a data set for the high income group with the race equal to 1. That means African American, and visit equal to 0. Okay, visit equal to 0. Let me see. Race equal to 1 means what? Race equal to 1 means African American. No, sorry, race equal to 1 means Caucasian. Race equal to 2 means African American. So the line of the data that is showing on the question number 18, I want to create a D4 data from original D1 data in such a way that the subjects with 0 visit, with a race, white race, Caucasian race, and income level 9 group people will be selected, because I want to do research only on this group of people. I want to do research on the group of people who have a white race, who belongs to income level 9 group, as well as during their baseline visit, first visit. Okay, how can you do that? This is the type of the date code you need in order to start doing baseline research for the Caucasians people or white people. Okay, so now if you take a look at that head df4, then this is your data. Take a look at the income variable. Are you seeing income equal to 999, right? And race equal to 111, and visit equal to 000. Okay, so this is the focus group. I want to do baseline comparison between African American and Caucasian. Now this is a Caucasian one. You can create a African American one, and then you can compare a baseline comparison between the important variables, how they perform in their baseline and how they perform in their last visit. Okay, you can do this. This is a very famous data, very famous data, but I have simulated by following their design. Okay, after this, now suppose I want to take a look at the first 100 rows. This is the first 100 rows. If I want to take a look at this data. First 100 rows, okay, of the D1 data. And this is the last 100 rows. Now I have to explain you what does this means. D1 1 to 100. D1 1 to 100. I said you before comma all operation would be on rows. After comma, all operations would be on columns. Okay, so that is why I write here D1 square bracket 1 column 100. So 1 to 100 rows. I want to take a look at the data D1. And then D2 and the second one is I want to take a look at the 20,801 to 20,900 rows. Okay, including all columns. Okay. After this, now I want to copy a data from the original. D1 is my original data. I want to keep it as it is. I don't want to add anything. I don't want to destroy it. I just make a copy of it, which is D2. So in order to do that, D2, I have created like this way. D2, I have just created like that way. Okay. D2 is the data. After creating the data, the D2 data, now take a look at the D2 data head. D2, this is the D2 data. So I have copied D1 data as a D2 data. Now all operations, rest of the operations, I want to do D2 and other new data that will be created subsequently. Okay. So take a look at the D2 data. D2 data has an ID variable, right? ID is a very important. I can know everything of your USM information if I know your ID, right? So that is why there is a name called the NDA, non-disclosure agreement. When you do any kind of research, you have to sign NDA form that you must not disclose or de-identify persons with their identification number. So they have some important medical conditions. They do not want to disclose it. Okay. They have some other informations like oil informations, how much money he has in the bank, which could easily be found by if their ID is known. So that is why I don't want original ID to be in the data. So for this reason, I want to create a new ID from the original ID. Original ID is ID and it has a number 100,011. 100,011, 100,012, something like that. But I want to create a new ID. Take a look. This is my new ID, head D2. Head D2. Now take a look at that. These are all same persons, right? Same persons. And they have the same new ID 111. Understand? I created that new ID from the original ID by writing s.numeric, the s.factor original ID. D2 is the data, $sign is the separator between data and variable. Remember, $sign is what? $sign is what? Moolah, right? Moolah. $sign is the separator between data and variable. Okay, so I took the D2 data, I took the ID variable from the D2 data and I convert it as dot factor. After as dot factor, I am putting it as dot numeric. So now it has become numeric. Okay, now new data, I have these things. I can delete the original data. How can original ID? How can I delete the original ID? Take a look at that. If I run these things. So this is the code. D2 data, I am taking only these two columns. Before comma sign are row, after comma sign at the column. This is the name of ID variable from D2 data. This is the name of the new ID variable from D2 data. I pick this up and I show this. This is what the two variables. Okay. This is the two variables. Okay. So now, after doing this, I want to take a look at the 1 to 6 column. In order to either you can pick this by the variable name or you can pick this by the position of the column. ID is in the first position, new ID is in the 26th position of the data. Okay, so the code that are doing in here, exactly same thing is done in there. Okay, so if I run this, take a look at that. If I run this, this is the same. This is the tail, last 6 rows of the ID and new ID variable. Okay, after doing these things, now I want to delete original ID. How can I do that? This is the code. The question number 23 is telling you how to delete original ID from the data. Okay, how to delete the ID from the original data. This is what is mentioned in question number 23. So now if you take a look at the D2 data head, D2, you will no longer see the ID variable. Are you seeing ID variable? No, right? ID variable disappear, right? So how can I do that? Just write D2 $sign ID less than hyphen equal to null. So that means I make ID variable disappear from the data. Now this is the data I can give my students. So now students do not know what is original ID. I put here new ID, right? 1, 2, 3, 4, 5. So if you, even if you know the people, you cannot disclose their things, because now there is a new data. Understand? So that is what, whenever you will collect data, get data, it is required to sign NDA. NDA means non-disclosure agreement. You have to sign with the company or institution who provides you public data with their information. Okay. Now I want to take a look at the summary statistics of the D2 data. So if you just write summary and D2, then you will get this minimum, first quartile, median, mean, third quartile, maximum, and not available. So D2 is the data. What I type, I just type D2, summary D2. Where is that one? This is what I just typed. Question number 24. Summary, all variables, their summary statistics is coming. Okay, all variables and their summary statistics is coming. Okay, so I provided 30 advanced computations by using R. Okay, you remember, like the function computations, those 30, and this is 100, and another 30 or 35 problem of test of hypothesis will be discussed next class. With this 160 or 170 data analysis, data mining, test of hypothesis problem, I will assign a project, and then code has been provided. You just need to use your magnifying glass, go through the Word document, find which problem relate to which data, and that locate that problem in your project and solve this. Very easy, right? Very easy, right? Very easy. But remember, the efforts, you need to give some efforts in here, please. And after taking this class, the winter time that you will find, okay, winter time break, you just use this data and this code to do all the things that I am doing in 170 or 60 data analysis, data mining, advanced computation, test of hypothesis, R code. You try to learn all of these things by yourself using Python. Remember, Python, I came to know first in 2015, but Python was existing since 1991. I did not know. When I came 2015 to a university teaching, there's in Python. I said, well, I know R, I know SAS. Let's see what is Python. I just saw a video. I said, no, it is the same as the R. Okay, both are interpreter-based language. So in winter, what is your task? Become a master of yourself. Okay, I have everything provided you in a very well documented thing. You can transfer it, these things, then you will be able to grow interest within yourself. Then you say, okay, I now know. Oh, okay, I now know. One step will clear, it will make your next step easier. One step, if you will forward, the next step will become easier. Okay. After this, now I want to find the summary statistics of one variable. So summary statistics of one variable is D2 $sign SBP. This is the summary statistics of one variable. D2 is the data, SBP is the systolic blood pressure, okay? And then this is the summary statistics of SBP variable. D2 is the summary statistics of, this is the summary statistics of the SBP variable, question number 25. Now, in these data, there are 25 variables, right? Let me check the data. Dimension D2, it has 25 columns. So if I want to take a look at that head D2, this is the 25. And each column has some missing values. How can I find that? Like the how many missing values for each variable, that could be done by using this. What is the code? Call means column sums, and then is dot na. Is there missing in the D2 data? And if it is missing by columns, find the column sum. Race has a 0 missing. Income has a 1152 missing. Age has the 1100 missing. Most missing is smoke. And then TC, total cholesterol, triglyceride, LDL, HDL. From by running this code, you said, well, my data has most highest number of missing values occurring in these four variable TC, TG, LDL, HDL. So when I do the analysis, let us see from which age these values are missing. Okay. So if you say that, well, most of the values are missing from age 17, 18, 19, then you can take subset the data from 9 to 17. You understand? Then when you see most missing values is appearing in what age, you have to do some kind of analysis on this variable. And then you have to prepare your final data based on what you see among your variables, like the which variable has the most missing values. Are you understanding? Okay. Is dot D2. Okay. After doing these things, now I want to create a column. So this is my D2 data. In D2 data, I want to create a column in here. I want to create a column in here. Here I want to create a column, and that column will have how many missing values in each row. Each row, how many missing values. So take a look at that. In order to do that, I just write these things. And then if I want to write here head D2, now and miss, okay, and miss. So first row has a 1 missing value, second row has a 4 missing value. In this way, if you find, because each person has a up to 10 visit, so if you see that some of these rows has a 15 missing, 14 missing, or 12 missing, 10 missing, then you said that, well, if the number of rows has more than 10 missing, I want to exclude them from the study. Are you understanding? So this is the second row has 4 missing values. Second row has 4 missing values. 1, 2, 3, 4. Are you seeing this code? So no missing value second row in here. First row has no missing value, only 1 missing value. Third row has 0 missing value. So if you find like that one, now if you find that, well, I want to take 0 missing value, so you can n miss equal to 0, that will be my data. I will do analysis on the complete data. Understand? Are you understanding? Okay, after that, now I want to do any row that has a missing value. I want to delete the entire row. Suppose one row has just only 1 missing value. That row will be deleted. Understand? So that could be done by running the code problem number 28. Problem number 28 would be used to do that. Now, if you take a look at that, in this data, are you seeing anything missing? Nothing missing, right? Nothing missing. Okay. Now, if you take a look at the dimension, if you take a look at the dimension of this, dimension D3, it has 1942 rows. 1942 rows. Okay. 1942 rows. So the data that has 1942 rows does not have one missing entry in each of the 1942 rows. This is the complete data. Understand, right? Are you learning something new? Are you sure? Are you learning something new? The project that will have questions, so you have to use this data. Okay? Yes. Maybe at the end of the semester. End of the semester, yeah. So I might assign the project next week or week after next week. Let me finish first all the materials. I have to give you all the materials, then I ask you tell me this, right? Yes. Word documents. Read those things multiple times, please. Okay? I request you, I advise you, and finally I give you very harsh order, like the military man. Understand? They order their soldiers, do this, do this. And if you work in the military, you cannot say, if your boss says do this, then you have to do it. Okay? So I ask you, request you, advise you, and then finally I give you order. Please read these three Word document and associated R code. You will become very good in doing your project. You will not have problem. Okay. After that, now I want to see the dimension and the summary statistics of. This is the summary statistics of D3 and D2. So then question number 13 is asking you, now compare the summary statistics between complete data without any missing and then data that has missing values. That is the difference of the question number 30. I want to take a look at the summary statistics between two. Okay. Now I want to find okay, what does this mean? What does this mean? This means I am applying, I am using apply function on, I want to find the standard deviation by column for this data. Understand, right? I am applying D2 data by column, their standard deviation. If I want to rephrase these things, I have to say that I want to find standard deviation for each variable of the D3 data that could be obtained by using this. But if I plug in here 1, then standard deviation for each row. Understand? If I plug here 1, then standard deviation for each row. Standard deviation for each row does not make sense because systolic blood pressure, diastolic blood pressure, raise, income, and height, weight, then standard deviation does not make sense, right? Standard deviation of systolic blood pressure makes sense. Standard deviations of height make sense. Understand? Okay, after doing this, how to find the minimum of systolic blood pressure? How to find the minimum of the systolic blood pressure, how to find the mean of the systolic blood pressure, how to find the median of the systolic blood pressure, how to find the maximum of the systolic blood pressure. Okay. Okay, after finding this, okay, so you remember in the central tendency, we learned mean, median, mode, right? Mode is what? The highest number of the observations that appears highest number of time in the data is known as the mode. Okay, so there is no beautiful formula for mode, so we have to write a one. So question number 33 is asking you to find the mode of the income variable. Income has a level, how many? Income has a level, if I write here TABLE table and then D3 and then $sign income, income has 1 is appearing 101, 2 is appearing 89 times, 3 is appearing 70 times, and highest number of things that is appearing is 8, 404 times, right? But how can I find this 404 times, which 8 is appearing 404 times by individually? Now it is table entire frequency we are getting, right? Table D3 dollar sign income, I'm getting the frequency for the income variable. But in order to find that specific one, we have to write a small function. See, find mod. You remember I told you, I showed you, and I taught in the class how to write a function. So find underscore mod is the name and then function of x. After writing that, then I'm finding unique values. So that means find only unique values, unique x. And then I have to explain these things. Unique values, unique values. So that means these unique values, the function that I write on the x, which dot maximum. So tabulate. I am doing tabulation of match x and unique values. X and their unique values and I'm finding them. And then finally, if I in this function, if I put now my name of the variable, it is coming. For example, if you want to do this, then 8 is the mod. Understand? 8 is the mod. Here is for the entire frequency table. 8 is the mod appearing 408 times. This is if I want to find the specific one. Okay. So 8 is the mod for income variable. Income variable has level 8 frequency, which is appearing highest number of times. After that, now I want to find any percentile value which could be obtained by using this. Okay. Okay. Now let me tell you, there is a quartiles, there is a deciles, there is a percentiles. Understand? Remember the word quartiles. First quartile, second quartile, third quartile. There is a decile. Quartiles divide the data in 4 equal parts once you arrange the data in ascending order. Decile divides the data in 10 equal parts when you arrange the data in ascending order. Percentiles divides the data in 100 equal parts when you arrange the data in ascending order. Percentile, quartiles, deciles, these together are called as quantile. Understand? Quantile, quartiles, decile, percentiles together are called quantiles. Okay? Quantiles. They together are called quantiles. Okay, so now in the SBP variable, if I arrange the data in ascending order, what will be the 63 percentile value? Okay, what will be the 63 percentile value? This is the 63 means that value will occupy in the 63rd positions. In the data, 100 positions, so this is in the 63rd. And this is the 97 percentile value. And then this is the way you can find the standard deviation. This is the way you can find the variance. And then 37 is telling you how to find the covariance and then how to find the correlations. Okay. This is what, how to find the covariance, how to find the correlation. What is the covariance? Can take positive value, covariance can take negative value, covariance can take zero value. One of the question in your first exam one, covariance can take positive value or negative value. Most of you said that yes, but they can also take zero. I give some point. I give 3 points. I give some 3 points, but after finish grading for all the classes, if I see that the student did not perform well, I will give some maybe 7 points, 5 points, or 10 points extra. I will add that. Okay. But at the end of the semester, when I see the overall performance, then I will do the final curving. Yeah, but not for you.
No, why? What did I do?
I'll do for whole class, okay? So you understand these things, and now CB means coefficients of variations, which could be done by using this formula, okay? But see, if there is any missing value, sometimes those computations could not be done. Some other formula could be done, some other could not be done. So in that case, I said NA dot RM. What does this mean? Take a look. This highlighted part, NA means if there is anything missing, dot RM means remove. Remove it. NA dot RM, remove. Understand? Remove it. So we are removing this and then finding the standard deviation of, coefficient of variation of SBP. So that means I am dividing standard deviation by its mean. So there is a standard deviation of systolic blood pressure, and there is a mean of the systolic blood pressure. We do this, okay? After doing this, okay. After doing this, now let me show you what I want to do. There is a head D3 data. There is a head of D3 data. And are you seeing SBP and DBP? I want to find the average of SBP and DBP. 101 plus 57 divided by 2. This is what I am to find. Then SBP has a 99 value, DBP has a 77 value. 99 plus 77 divided by 2. This is what I am to find. And create a variable name average blood pressure. So this is what could be done by running this. Now take a look at that. Head D3. This is what ABP value I have created. Average blood pressure value I have created, okay? I have created this by taking the average of SBP and DBP. That is the code I have shown in there. Now, after doing these things, I want to, this could be done also by using this approach. I am taking SBP and DBP from D3 data and finding their row means. This is the another approach. This is the another approach. Take a look at that. Head D3. This is the another approach. So these are the same thing. This is the same thing. Okay. So two different line of code which is written on this and that. These two are the same code. Okay. These two are the same code. After running this, I want to create a blood pressure category variable. Okay. I am not going this Word documents more frequently. This is the problems written in Word format, and that is the code. As it is my head, I am not switching because I take a look at the code. I immediately understand what I am doing. But your main point of understanding is this Word document. Understand? Main point of understanding is this Word document. Please read these 2-3 times before going to the bed today. Okay? So that you will understand what type of coding I'm doing. Yes, gentlemen. This code that I'm showing. This one or this one? This one is already in there in Canvas. It is in the Canvas. I uploaded it yesterday. Okay, so now what I want to do, ABP variable I have created. If ABP, which is this ABP, if ABP greater than 100, I want to give them as a level 1. If ABP is between greater than 85 and less than 100, then I want to give a level 2. If ABP is less than 85, then it will be 3. So each of these categories is mutually exclusive. They do not overlap. See, first one is greater equal to 100. Second one is greater than 85, less than 100. So this is non-overlapping, right? So no observation is cutting off the way I have written the code. Okay, there is nothing overlapping. So that is the way I have created a BPC variable blood pressure category. If you take a look at that, D3, this is the blood pressure category level 3. If less than 85, then 3. If between 85 and less than 100, then this is 2. So by using these values, I have created blood pressure category level. Clear? Clear? Sometimes you have to create some binary variable in order to run logistic regressions, because between this category you can easily compare. Even if your variable is quantitative, that means continuous, but you need to transfer them to category in order to make a comparison between comparing category and reference category. Okay, after this, now I want to name as a, if A equal to 1, then I want to name it a high blood pressure level. 2, then I want to name it as a median blood pressure level. And if 3, then I want to name it as a low blood pressure level. So that means numerical number now will have character value. Okay, so if I run this and then take a look at that one now, are you saying blood pressure category variable has been created? Okay. So I first created average blood pressure, then I created blood pressure category. Now I created blood pressure category level. Okay, these are the things I have created. After doing this now, okay, I think I have 1 hour 45 minutes. I would be able to finish it. Okay, clear, right? So now I want to do table. I want to do bivariate table. Bivariate table, that means what? Bivariate table means blood pressure category has a 1, 2, 3 level. Race has 2 category, African American and Caucasians. 1 stands for Caucasians, that means white, and 2 stands for black. I want to create a bivariate frequency table. So blood pressure category 1 with Caucasians, we have only 19 people. Okay, that's the way you have to read the table. Blood pressure category 3 with African American race, there are 486 persons. That's the way you have to read this table. There is a trivariate table also, bivariate table, univariate table. This is frequency, trivariate one. The trivariate one you can write like this way, and I need to explain these things. So income has 9 level, right? Income has 9 levels. See, this one is coming first, income. So income equal to 1, income equal to 1, and then BPC, blood pressure category has 3 level, right? 1, 2, 3. And then race has a 2 category, 1, 2. Race is 1, 2. So this one is income category 1. This is income category 2. This is income category 3. Each of them has a blood pressure category 1, 2, 3. And then each also has a 2 race. Trivariate. Okay. So now I want to subset the data. I want to create a data where total cholesterol exceed 162 and weight is less than 62. I want to focus on the research of those people who have weight less than 62 pound, or who have no 62 kg. This is in the kg, 62 kg, and the total cholesterol in 162. Okay, these are some benchmark level. These are some red line levels. I want to subset this data. I want to focus study on this data. Are you understanding? Are you understanding? Not tired, right? Good, good, very good. So this is the way you can subset from big data to a small data and focus study on that data. Okay, and then after doing this, let me do this. And then if you take a look at this one, head df6, this is your data. And in this data, if you find like the minimum of df6 $sign, and then if you just put the wt, and you will see wt, and then see the minimum value is 26.1 minimum value, weight value, and maximum value, if you write, it would not exceed 62. Take a look at that. It would not exceed 62 because that is the 62, right? The maximum value is 61.95. Because I said that weight must be less than 62. So highest weight is 61.95. because I want to focus study on this group of people. Okay, so after this, question number 45. Let me see what the question number 45 is telling. Create data where maximum value of SBP variable is selected by ID number. Okay. Okay. Each person is appearing multiple times, right? That persons with their highest number of SBP value. So suppose you are appearing 10 times, you are appearing 7 times, she is appearing 8 times, I am appearing 11 times. Among these 11 times I am appearing, I have 11 ID. Among these 11 times, my maximum blood pressure one I want to select. So each person's their maximum blood pressure will be selected. From lot of rows, there is a one person appearing 7 times, one person appearing 11 times, another person 10 times, 3 times. I want to select each person by their highest blood pressure level. Then I can focus on study on the blood pressure when they have the highest blood pressure level. That could be done. Let me show these things. That could be done. See, SBP is the dependent variable, and I want to take by the new ID data equal to D2, function equal to maximum NA dot remove. That is the way D75 data would be coming. So now take a look at that. And if you write it in here, DF7, and then DF7, if you write here head, this is the data. Okay. So this ID number 1 has maximum 109. ID number 2 has a 122. See, this is the new ID. Okay. Now I have to merge this data with the original data by ID variable so that I will get my record data. You understand? This is thus I selected the rows. Now I will merge it with the original data by this ID number so that I will get the original data. Now see, next one, I merge it by this. And here is the new data. DF8, here is the new data. So in this case, if you take a look at the, where is my new ID? Are you seeing the new ID? 1, 10, 100, 1000, like this way. Okay. So it has been done with the D2 data, not D3 data, because D2 data, D3 data does not have a missing value, but D2 data has. Okay, but that is the way. So, and then 45 and okay. So now DF data, I want to select the unique. This is the unique one. This is the unique one. There is some, okay. You might have problem when you go home after running these things. You will see that there is a some number of observation appearing twice. The reason is that, listen carefully. When you run these lines of code in the 45, you will see the row number is increasing. Why row number is increasing? Because when we merge D2 with the DF7, so DF7 has the same ID and same maximum blood pressure twice. And then when original subsetted data has only one, but they match, they are saying they have the same appearing 2 times. So that is why it is appearing 2 times. Okay, say D2 data has the ID number 1. It has the 2 highest SBP 109, 109. Okay. D2 data has ID number 1. It has 2 highest SBP 109, 109. But original D7 data has only 1 row with the number of ID is 1 and the highest value is 109. But when this is merged, he is considering both of them. So that is the number of rows increased in the merged data DF8. But in order to reduce that to the original size, I will select only unique ID. Then it will be stable. Some 1-2 problems you might not get it immediately, but you give some of your thought each of this problem, you will understand why these things happening. Then in order to overcome that, I have to write a line of code, which is this. And then in that case, these data will have exactly same row as DF7. DF7 has a less number of row. DF8 has a little higher number of rows because of the ID number and the SBP is appearing same values multiple times. That's the reason. But when you subset it by the unique, then you will see that it is same. Okay. Now the question number 46 is asking you find the mean of the total cholesterol variable by race. Race has African American and Caucasians. If I run this, so you will see these things. Come. Okay, so what does this aggregate means? I want to find the mean of the total cholesterol by race variable. Okay, mean of the total cholesterol. Total cholesterol mean for the Caucasian is 164.15. Mean of the total cholesterol for the African American is 164.48. Here, this is called the aggregate function. And then this is the SBP for the race variable. And I want to take a look at their variances. Okay. And okay. After doing these things, now from the original D2 data, this is my original D2 data, dimension D2, 20,900, original D2 data. Okay, original D2 data, there is a repeating ID. I just want to select unique ID. Now take a look at this one. Now, if you take a look at the dimension D4, 2,379. So what I did on this problem number 48, original D2 data, I want to take unique ID. That means if a person appearing more than one time, I want to select just only one time. Okay, that could be it. Okay, this could also be done by using these packages, but they are the same. We can also use these things. Alternative. Okay, if something appears like this way, this is called the hub. Hub means R repository. R repository is when you download now any packages, you have to download it from online. Online somewhere it has a repository. It has a cloud storage. Okay, its hub is London. UK London is the hub, but America also has a places like USA. I think this is Utah, this is Tennessee, this is Pennsylvania, Oregon, Ohio, Michigan. Okay, but sometimes people do it in just the London. So our closest one is Tennessee, right? Tennessee is the closest. So I can go there and take the Tennessee. This is the CRAN mirror, they said, or also known as the hub, where the all repository is in there. So all packages, everything is set up there. So this is the alternative way we can do this. Okay. After doing this, now check the dimension which reduce significantly. Okay. Now bar chart is done for what variable? Qualitative variable, right? Bar chart is done for the qualitative variable. So this is the, I want to see the bar chart for the income variable, which is question number. I want to write them. D4 is the data. I want to find them as a income. Level is 1 to 9. And I want to put the level 1 to 9 as a levels. This is the levels. Now I want to put them EP, extremely poor, poor, middle class poor, low class, lower class medium, medium, upper, like the lower rich, medium rich, extremely rich, something like that. I put the name and then I put the bar plot table labels, these labels and main bar plots. So that's the way you can construct the bar plot and show it in there. This is your bar plot. Okay. And there is a colors. Let me see what color did I put some color name in there or not. I think, yeah, color. See, white, red. Are you seeing? White, red, navy, marble, blue. All of these things could be put in there. Okay. So you have seen how to do the bar chart for the income variable. Now you can see the pie chart for the income variable. Okay. This is the pie chart for the income variable. Pie chart for the income variable. And now pie chart for income variable. And now I want to do 2x1 graph. So let me explain what does this mean. Take a look at the board. This is the par. Par stands for parameter. Okay. Par stands for parameter and then parenthesis M for multiple, F for figure and row. Multiple figure by row. 2 row, 2 column. It will go row 1, 2, 3, 4. 2 row, 2 column. Okay. So I want to show you 4 figures. Now I want to show you figure. This is the 2 figures of the white race, like the white and African American in bar chart as well as pie chart. Okay, 2 figures, 1 row and 2 column. 1 row. Are you seeing 1 row? This is the 1 row and this is the 2 column, 2 figure. Okay, the 1 comma 2. Okay, 2 by 2 graph. Now I want to show you 2 by 2 graph. 2 by 2 graph. This is 2 by 2 graph. Okay. 2 by 2 graph, low smoke category 1, 2, 3, 4. Smoke categories. Let me see. Let me see. Okay. Okay. It's a bar plot. Y limit I instead of 1800. I should put here. Let me put here 25. Now you see the graph title would not fall in there. Previously, bar plot was coming in here, right? Now it is not because y limit means y axis limit. X y lab, y lab means y axis level. Okay. Y lab means y axis level. X lab means x axis level. What level you are putting? I put their level smoke categories. Okay. So and y lim means limit. How big or small limit you want to make? Y limit. X level, Y level. Are you okay? Okay, so now so far I have finished 52 problems. 2 by 2 graph. Now stack bar chart. Stack bar chart means if you want to compare two qualitative variable. If you want to compare two qualitative variable, let me get rid of these things. Let me get rid of these things. Let me minimize these things in here. Let me get rid of this. If you put here div of, this is called deviation of. So that means the grid that you have created 2 by 2, the figure would not go there. Div of if you rate, so it will get rid of all the grid. Okay. So now if you put here this thing, see beautiful graph, right? This is called the group bar chart. Okay, this is called the group bar chart, and that was known as the stack bar chart. This is known as the stack bar chart. Group bar chart means here income category 1. This one is Caucasians, that one is African American. Income category 2, blue is Caucasians, and then that one is African American. Okay. Are you understanding? So two categorical variable, and you want them in like the one category you are taking and then comparing them to. So income category 1, African American African American and Caucasian. Income category 2, African American and Caucasians. Okay. Okay, after this, I have shown you both of them. Now I want to show together. This is the both of them side by side. One is group bar chart and another one is stack bar chart. Okay, this is the I want to show you. This is called the stack bar chart. This is called the group bar chart. African American, and Caucasian and African American, Caucasian and African American, Caucasian and African American. Within extremely poor and middle class poor. Okay, so this is the category. In here, within income category 1, this is the African American and that is the Caucasians. That's the way you are showing your graphs. Okay. Now I want to do dot plot. Dot plot means the plot that you want to have by observations number. Here is the observations number and here is the SBP values, dot plots. So observations like 1, 2, 3, 4, 5, 6, like observations like this or 2000 numbers is in there, and then you want to see the values. Observation number dot plot. Now, if I want to do the one dot plot for the African American and one for the, this is the dot plot for the African American and this is the dot plot for the Caucasians. First, I subset the data by race variable. When race equal to 2, then it is African American. When race equal to 1, it is Caucasians. Now I want to do the histogram for the SBP variable. Now I want to do one histogram for the African American. And then I want to do another histogram for the, here one histogram I want to do for the African American, one for the Caucasians. Okay, now I want to do the box plot. This is the box plot, and as you know, box plot has from the box plot we know 6 informations like the minimum, maximum, first quartile, second quartile, third quartile, and outliers. These are the 6 informations we know. And from the histogram we know model class, as well as know the types of the curve, right? These 8 things we know from the box plot and histogram, got basic. Okay, so this is the thing. This is the box plot that you have seen. After seeing this box plot, now I want to see box plot by the race variable. This is if you plug here race, and then SBP. Race is 2 category, African American and Caucasians. Name of the data is D2 and box plot for the SBP variable for 2 races. So then you will see this type of graph. Okay, you will see this type of graph and you see graph 1 has more outliers going out, higher outliers compared to the graph 2. Graph 2 is for the African American and this is for the Caucasian. These are the 2 races. Okay, and then African American has a higher median and also their first quartile and third quartile is also higher compared to the Caucasians. That's the way you have to explain your graphs. Okay. So graphs you will have to explain from here on. First quartile, median, and third quartile is higher for the African American compared to the Caucasian when you consider systolic blood pressure. That's the way you have to explain these things to your audiences. Okay, now I want to see all 9 graphs together. So 3 dot plots, 3 histogram, 3 box plot together could be obtained by running this. Okay. So first are the dot plots. First one for the entire data, second one for the African American, third one for the Caucasians, and the same variable SBP is used in creating these 9 graphs. First 3 are the dot plots. That means observation number and observation value are put in x-axis and y-axis. Second one is histogram and third one is box plot. Okay. After this, now I want to do what? Okay. Now I want to do, this is called the very fantastic plot. it has, okay. Now in the x-axis, if I put height and y-axis, if I put weight, then this is called the scatter plot. I have a height and weight, right? Height is put in the x-axis and y-axis the weight. You have a height and weight, so x-axis and y-axis. If this is the way two variables are put into different axes, then the plot is known as the scatter plot. Okay, now we want to see scatter plot and their histogram, because if my height is with my height, then it will be what? It will be histogram. You height with height, then it will be histogram. Okay, so now I want to see some histogram as well as scatter plot together with correlations of the variable. That could be done by installing a package known as the site package, and then you can do these things. Okay, take a look at that. What does this mean? I have put here four variables: SBP, DBP, triglyceride, and TC. TC means total cholesterol. Are you seeing? This is the total cholesterol with total cholesterol, but that one is total cholesterol with triglyceride. Okay. This one is the scatter plot of total cholesterol and diastolic blood pressure. This one is the scatter plot of total cholesterol and systolic blood pressure. So these are scatter plot. Okay. So this is the scatter plot of total cholesterol and triglyceride. Understand? And this one is the scatter plot of total cholesterol and diastolic blood pressure. Okay. Here total cholesterol, here is diastolic blood pressure. And these are the correlations. So the highest correlation that we are seeing, 0.33, is the correlation between SBP and DBP. Clear, right? This is a very important plot. From this plot, we see scatterness between two variables, as well as their histogram, as well as the correlation between the variable. Lowest correlations between variable are total cholesterol and diastolic blood pressure, right? As well as total cholesterol and DBP. That has the lowest correlation, 0.02, right? When graphs are created, you need to know how to explain that. Are you okay? Are you okay? So take a look at the question 64. Construct scatter plot, histogram, and correlation matrix for SBP, DBP, TC, and TZ. Please read the Word document. Understand? After that, construct scatter plot with the marginal histogram. Okay, so now I want to do scatter plot with marginal histogram. In order to do that, I have to explain these things. What does that mean? Okay, what does this mean? This means in this case, I put the SBP. In this case, I put the DBP. So in x-axis, I put the SBP, y-axis, I put the DBP, and this is the scatter plot. But at the top, this is the histogram of the SBP. This is the histogram of the DBP. Okay, so from there now you can say that, well, yeah, both of them look like the normal. So if you put a smooth curve over there, both of them looks normal. But some of the cases you said that, well, one is skewed to the right and another one is symmetric. Both of them is skewed to the right. Why this graph is important? They will give you histogram together with the scatter plot. Understand? And then you can say that from the scatter plot, you can say that there is a like increasing trend. So one is increasing, other is also increasing. It is going like that way, right? So this is called the scatter plot with marginal histogram. Okay, scatter plot with margin. This is what known last graphs that I have started showing is called data visualizations. Okay, data visualizations. So there is, I think, maybe 14, 15 problems of data visualizations. Okay, now let me, what happened to this? I don't know what happened. Okay, so data visualizations is this marginal plot. Now let me do next one, 66. Okay, this is what known as the, I had created blood pressure level, right? High blood pressure level, low blood pressure level, and medium blood pressure level. And in the y-axis, I put SBP, and in the x-axis, I put the blood pressure level. And this is known as the violin graph. Violin graph means all the data. So take a look at them here. In low blood pressure, only few data is in there, and most of the data in the middle, and some of this data in extreme tail. But on the high blood pressure, so again, few data is in there, but are you seeing most of the data in the middle of this thing? Okay, violin means what? All the data has been put it in there, minimum and maximum, all the how they look like. It is called the violin graph. And how they construct these things? They constructed these things by density estimation. By they use the data, they use the density estimation method to construct one side of the curve, and then they mirror it exactly other side. See, this is symmetric. If you plug it and put it in there, it's exactly symmetric. Okay, so in this way, what the violin is telling you, so in such a cases, for the medium blood pressure one, that one, are you seeing only few observation is the extremely high end, rest of the things are in there. Okay, most of the data in the middle part, and few data is in the up, few is in the bottom. So entire data are shown in this graph. This is called the violin plot. Okay, so now let me see life expectancy, GDP, and population size. In our case, like this. Control R. So let me explain these things to you. Violin graph. Construct bubble chart with height, weight, and BMI variables from default data. Okay. So bubble chart means what? Are you seeing the size of the bubble are not the same? Size of the bubble is smaller and bigger, right? So that means if bigger things is happening, more frequencies in there. If it's smaller bubble, that means smaller frequency. So this is appropriate when you want to find the size of the populations by the life expectancy and GDP. So that means, and as well as population size. These three, if you want to plot, then you will see the three-dimensional plot. Here, height I put there, and then weight I put there. And height and weight after putting, I put another one, which is known as the BMI. So the BMI is the plot, is the dot. So corresponding to height and weight, if there is a very big BMI, then bubble size is bigger. Okay, that's the explanation of this. So this is a three-dimensional plot appropriate when if you want to show some specific characteristics based on two other characteristics. For example, GDP and life expectancy, if you put an X and Y axis, and population size if you want to put, then you will see bubble chart. Okay. Then after this, if you want to create a line chart, this is the line chart. The line chart is I have taken a random sample of size 20, and then I ordered them by age and SBP. First of all, I ordered them by age and SBP. Age I put there and SBP and then I want to connect them by the line. That is what it is known as the line chart. Sometimes in your case, line chart could be of importance. Okay. Now density plot. So I want to do the density plot of the SBP. So this is the density plot. Like density plot means histogram is constructed and then at top middle point of the each bar, then this is called the density. Density looks like maybe symmetric. Okay, density looks like symmetric. And then QQ plot. QQ plot means what? I'm going to discuss this. Okay, I have 1 hour. I would be able to finish it. So what do you mean by QQ plot? QQ plot means you remember within 3 standard deviation, what percentage of data fall if your frequency curve looks symmetric? 99.7%, right? So within 3 standard deviations. So here is the theoretical context. That means 3 standard deviations. So 3 standard deviations from mean to the left and right. So that is a +3 and -3. Okay, this is the theoretical quantile, and this is the quantile coming from my sample data, which is SBP. Okay, which is SBP. So QQ norm and then QQ line. I want to see if they put one over the other. If there is a straight line, that means all the dot that will fall in the red line, then it is a normal. Otherwise, it is not. Okay, that is the explanation. QQ plot means what? You have a sample quantile, and sample quantile you are putting over a theoretical quantile. Theoretical quantile means -3 to +3 within mean 3 standard deviation, 99.7% data fall. Okay, and then you have a theoretical quantile in the x-axis and sample quantile in the y-axis. If these two lines coincide, then that means you have a normal distributions. That means symmetric distributions. And finally, heat map. Please read these things. Heat map. The data that I have is not appropriate for creating a heat map. So instead, I simulated data, and from that simulated data, I created a heat map. If I plug this, if I run this, then I have to explain these things. What does heat data melt is not found? Data melt is not found. Okay, I think I have to install a package. I think it's deeply. I think I have to install the package reshape. Install dot package reshape. Install dot package reshape. Okay, let me plug it in there and run it. I hope it will work now. Library reshape 2. I hope it will work. Now let me see whether it will work or not. Data has been run there. Data melt. Okay, now I hope it will work. Here is the okay heat map. The explanation of the heat map, I have given the total descriptions in there. Are you seeing this part of the code have some texts? So this is the way I explain what does heat map. If blue and red, so take a look at this case. A heat map is a, let me go there. Windows style horizontally. And then if I want to put here like this, so see what does heat map means. A heat map is a data visualization tool that uses a grid of color cells to represent the magnitude of values in a data set with different color indicating different levels of intensity or activity. So color is white, more intense. Color is blue, less intense. By using color gradients, heat maps allow users to quickly identify patterns, trends, and anomalies within large and complex data sets. Common example include website analytics showing user clicks or eye movement, biological data displaying gene expression labels, and geographical maps indicating population density or temperature variations. A color scale or legend is provided to explain what each color signifies. Typically, warmer color like lead and orange indicate higher values, and cooler colors like blue indicate lower values. So that is the heat map. So the data that I have is not enough to create a beautiful heat map, but this is the text of explanations how heat map is consist of a color, and then if there is a red color, so that means high intensity of those events, of those occurrences, and if the color is blue, that means less intensity. So let me go there and run it again. This is the heat map, okay? 100 random data sets are generated and they are put in 10 rows and 10 columns. And then with those data, we want to see by arranging them 100 data points in 10 rows and 10 columns, which has the highest intensity. So that is done like this heat map. But it could be better if like some special data could be arranged in that case, like highest intensity of the extreme weather could be seen easily by plotting the weather data, maybe heat, temperature, or snowfall or rainfall, something like that. Okay. So now let me go to make it again window style vertically. Get rid of that things completely. Window style vertically. Now fine. Okay, so that is gone. Now question number 72 is asking you D3 is the data. From that data, I want to take a random sample of 200 rows. D3 is the data. D3 data, I want to take a random sample of 200 rows. See, sample and row D3 data 200. I want to take a and row D3 of size 200 rows completely randomly. Replace is false. So that means the same row cannot appear more than once. Okay, I want to take a sample of that. Now, if you take a look at the dimension, new data, you see there is 200 rows. If you want to take a look at the head of the ND data, this is the head of the ND data. Okay, now if you want to take a sample of size 200 from the SBP variable, this is the way, this is the sample of the 200 data points for the SBP variable. Okay. Okay, now after taking this, if you want to construct a stem, leaf, stem and uh, stem leaf plot. Okay, stem leaf plot means what? So the decimal points would be in here and the stem point, non-decimal integer values would be in there. So this is the places they are considering here 80, 82, 84, 100. How many times 100, 101, 102? This is coming. They have put like this. So this is the way stem leaf diagram are constructed. Okay. So for example, 80 is appearing 1, 82, 84 is not appearing at all. So if you take something in there, take a look at that. Short. Okay. 80, 82, 84, 86. Okay, so the reason, okay, let me explain these things to you. Are you saying I do not have a 80 in there, right? 80 is not in there, right? But are you saying 80? So that means 81 to 82. This is closest to 82. So that is why 81 is considered as the 80, then 82, then 84, then 86. So 82, nothing is in there. Corresponding to 86, only one number, right? Are you saying? And then 88, they put there 88 equal to 1, 2, 3, 4. All of this is 4. 0 put corresponding to 82. Okay. Sorry, corresponding to 88. So they have a jump, 2 point jump, and all the values in that points they put together. And now if you draw a smooth curve over there, it looks like symmetric, right? Like if you draw a smooth curve like this, it looks like symmetric. Stamley plot like that way is constructed. Okay, so now let me go to the original data again and bring the original data again. Now I want to subset the data by excluding ID variable, TC, TG, LDL, HDL, smoke. These are the variables that has the highest missing. I do not want them, so that is why I'm excluding them by putting a negative sign in there. Are you seeing I put a negative sign in there? Negative sign, right? So that means these variable in these data N1 from D1 data are not selected. Okay, so take a look at the questions that I have in there. 75, question number 75. Create a N1 data from D1 data by ignoring these variable. I do not want these variable in my data. So I put the D1 data. I put the D1 data, subset D1 data, select equal to negative of these values. So that means these that I do not want. So now if I go there, take a look at that dimension of D1 equal to this. And then if I want to put dimension of N1 equal to that. See, those 10 variables are deleted from the new data known as the N1. N1 is the new data. Okay. Are you okay? For undergraduate class, I teach all of these things in 2 or 3 lectures. But as you are graduate, grown up, smart, self-independent, making your own money, making your own decisions. And I'm teaching it in a very simple way, right? Beautiful Word document, all the code with the explanation, and overall I'm recording the things for you. Okay. If you go home and if you do not put efforts, nobody. And nobody at the university or higher level, if you complain, they will, no, Muhammad is giving you everything. Why are you complaining? Everything is recorded, right? So now this data has been in there. The purpose is to show you, is to give you training how to work with the multiple data set at once. You have a data in Mississippi, you have a data in Washington, DC, Massachusetts, California, all the 50 states data is in there, and you want to work at a time with the all 50 states data together. 50 data sets, I want to work together and want to find their minimum income, maximum income, average age of death, average age of longevity. Okay. What is the difference between average age of death and average age of living? Average age of death, average age of living. Average age of death means after birth. Average age of living, I already lived 50 years, right? So my age will start from now to the rest. So that means average age of living means from now to the rest, because those are the things we already passed, right? So that's the difference. So the reason now I want to show you how to work with the multiple data sets. Understand? How to work with the 100 data sets, how to work with the 50 data sets. USA has a 50 states, world has 206 countries. Okay, I want to work with the 260 countries data. Okay, and then how can I do that? So in order to do that, after selecting this, now I want to get rid of any missing values that I have in N1 data, and I want to see the data head and 2. This is the data. And in this data, age has this. I want to round the age variable to 1 decimal place. So now see age is new age. See, new age nice 9.3. Previously it is 9.35. So for example, 11.2. So 11.3. This one is 11.3. Okay. This age is round to 9.3. Okay. Original age variable is rounded to 1 decimal place. That is what this code is doing. Round age variable to 1 decimal place and name it as a new age, which is new age. New age is constructed from the age variable. Okay. So now take a look at that. After that, I want to subset it further. That means age should have value greater than 9 and less than 19. Okay. So this is the way. In this data, if I want to write summary and to $sign new underscore age, then I see like this. Okay. Are you saying now 9.1 to 19? Because I subsetted the N2 data by taking age greater than 9, less than 19. Okay. Are you saying summary 9 greater than 9, 9.1, less than 19, exactly 9. Okay. Now 9.1, I should have a one data. 9.2, I will have another data. 9.3, I will have another data. And 19, I will have another data. So instead of one data, now I will have 100 data. If I split them by age. Now you are going to learn. So, okay. So this is suppose my data. N2, this is the data. I have done all of the above thing. Now this N2 data I want to give to you. This is the R, right? I have N2 data. How can I give this data to you? In order to give that data, I have to run this. See, write.csv N2 file N2.csv. Okay. If I run this data is gone. Where? To my directory. You remember directory that I declared? Okay. Now, if you search here N2.csv, right? If I write here N2.csv, are you seeing N2.csv? Okay. Now this is the N2.csv. This is the data. It has been saved in my directory. This is the data. Okay. Now this is the automatic column they have created. If I do not need, I just need to delete these things. Okay. So when you become the manager, data manager or database administrator, you will do this type of thing and give the data to 3-4 people and ask them who can do this work. If the person who is doing the work within 2-3 hours and report to you, give him promotion, give him salary increase. Okay. And fire 2-3 who did not do it within 1 week. Okay. Rebuke them publicly. No, you can never do that. Do not be a boss. Okay. Be a leader. Okay. Do not be a boss. Do not show. If the people who want to come under your supervision, be kind to them. Teach them. They might not have some kind of proficiency in 1 or 2 areas, but that person might have other proficiency. If you nurture them, they can do better. So Bill Gates has one philosophy. He said, if he wants to do any difficult task, cumbersome tasks to be done, then he try to find most laziest persons in his team. Because he is the lazy guy, but when he was given something to work, he dedicated all of his time, okay, to do that. This is what his philosophy is. And throughout your lifetime, remember that if you hire some people, if you do not see that he is not doing well, giving chance one after another, 2, 3, 4 chance. Okay. After that, he is not, then you can take the decisions. Okay. So this is the way you can clean the data, make the data, and give it to the people who is working under your supervisions. And make sure that data is de-identified. Okay, the ID variable, either you delete this or you create a new ID and put it in there so that they cannot identify the persons. So this is the way you can export the data. Okay, so you can export the data, and now I want to split the data by new age variable. Okay, so N3 is the data. N3 has now 100 data sets. See, if I write here length, if I write here length, if I write here length N3, how many? 100 data, right? First data is for age 9.1. How can I say that? How can I see that? Head and 3. This is the first data. I write here head and 3 double square bracket and then closing the parenthesis. I got the first data corresponding to age 9.1, right? Are you seeing all age is 9.1? So I got the data for age 9.1, okay? Now take a look at the second one. Second one, if you want to take a look at that, go there, up arrow, second. This is the data for the age 9.2, right? And then up arrow again. If you plug the 3, this is the data for the age 9.3. Okay. And then if you want to go there, 99, this is the age for 18.9 age. And this is the, I substituted the data by age, right? This is the age 19. Remember, age greater than 9, age less than 19, right? So how many data sets now? How many data sets now? 100 data sets, right? 100 data sets. Are you seeing length of N3 equal to 100? Like this is what I showed you. Length of 100, length of N3 equal to 100. Are you seeing? So that means N3 is a list. In that list, we have a data 1, 2, 3 up to 100. List means what? In 90s, when the husband go for shopping, wife create a list, right? In that list, paper and pencil, there is a, you bring sugar, you bring salt, you bring fruit, right? All of this is listed. And then husband go there, come home, and wife said, oh, you need to bring these things. And then husband become mad. Why did I ask you to list these things down? Right? But now there is a cell phone, there is everything, okay, bring this, bring that. During that time, people go to the market 2-3 hours and come back, they said there's no salt. Okay. So list, that means it has everything. N3 is a list that has 100 data. Are you understanding? N3 is a list that N3 holds all 100 data. Now I go, I equal to 1, first data. I equal to 2, I go second data. I equal to 3, I go third data. I equal to 100, I go 100 data. And for each data now I want to find mean, minimum, maximum, standard deviation, variance. Are you understanding? That's the way now I can work with the 100 data sets. Clear? So if you have a data, big data, big data, and from the big data, it has all 50 states. How can you work with the 50 states different data? You have to split the data by state and then run a loop for I equal to 1, Alaska equal to 2, Alabama alphabetically, and then you will find their longevity, average household income, minimum income, maximum income. Okay. All of these things could be obtained if you know this type of code. So now I want to, after these things, I have shown you the length of the data, which is 100. And then I want to see the dimension of the each data. Take a look at that. Past data has 69 rows and 16 columns. Okay. So I run a single small loop. I equal to 1 to length of N3. That means 100. And then D equal to N3I. I equal to 1. And print dimension of D. I want to see the dimension of the D. Okay. And then if I see 69 and 16. If you don't believe me, let me show you. Dimension and 3, 1, and C. How many? 69 and 16. This is by 1. 69 and 16, right? Are you seeing 69 by 16? Now, if you want to see the second one, just go there, change it like this. 19, 90 and 16. 90 and 16. Okay. So this line of code is just running a for loop, one for loop to check the dimension of each data in D3 list. M3 is a list which hold 100 data. And I want to see each of the 100 data's dimension. How many rows and how many columns. That could be done by using this. Understand? Now I want to print summary statistics for SBP and DBP for each of the data. Each of the data summary statistics. So take a look at that. Each of the data. This is the summary statistics for SBP for the first data. This is the summary statistics for the SBP for the second data, where A is equal to 9.1. Okay. So if you want to check whether this looping is working or not, I want to show you something. You can write a summary. Oh, you can write a summary, and then N3, and then I want to write here N3 1. Okay, and then I want to put here dollar sign SBP. Are you seeing 80, 95, 100, 100, 105, 120, right? 80, 95, 100, 100. Come here. 80, 95, 100, 100, 105, 120. Okay, looping is very good, right? See, just this line of code, right? Just this line of code, right? Are you understanding? That's this line of code, you are getting a lot of things, right? Only few intelligent people, they come up with those ideas. And how they have developed, how they have done this, we don't know. Actually, I don't know how all of this work inside there, inside the art, how they come up with the console, how they do all of this. Now, do you know how the touch phone works? No, right? Only few talented people who are developing, doing fundamental research, they know all of this. Right? Similarly, if I want to find variance, we can also find the variance. This is the way you can find the variance one. I have put here multiple for loop things so that you can understand how to run loop and work with the multiple data at the same time. So that is why I check the dimension, I split the data, I check like summary statistics. Now I'm doing the variance, all of these things. Now I want to do what? Now I want to do I equal to 1 to 100. Length of N3 equal to 100. So I take one value, so D will be the first data. If I take second value, D will be the second data. Then I take these D when I equal to 1 first data, D dollar sign SBP, and find the mean and round it to the 1 decimal places. And the next one is minimum, maximum, variance, median. And I want to put the mean, minimum, maximum, variance, median for the 100 data sets in a data frame format. See how beautifully it is showed up. Okay, now what does this mean? What does this mean? The highlighted part. So I create a matrix that currently has NA, nothing available. Okay. Currently it does not have anything, but it has a length of N3, length of N3 equal to 100. And that means row equal to 100. And 5 means column equal to 5. I am creating a empty matrix that has no element, but it will have 100 rows and 5 columns. Understand? If you are hungry, if you come to my home, I say, I'm hungry, I'm hungry, I'm hungry. I will give you an empty bowl first, right? And then I'll put their cereal, I'll put their meal, right? So this is the empty bowl. So mat11 is an empty bowl. I am creating an empty bowl and then invoking this empty bowl inside the loop. Are you seeing? Where is that one? Yeah, mat11, right? Are you seeing mat11? Mat11 is created. Mat11 is created outside of the loop in here. Loop starts in here, ends in there, right? Loop starts in here for I in 1 to 100. Loop starts in here, ends in here. Within loop, I put this M11. Are you seeing? So this is the empty board, but this all stands for this one, this one, this one, this one, 5 column, 1, 2, 3, 4, 5. That is the 5, okay? And then length equal to 100 because 100 rows. So that means I have created an empty bowl there. I'm invoking it within the loop and then finally getting the output in there. Understand? So this is the empty bowl that I am creating in there, which has nothing in there at this moment, but it is an empty matrix which has 100 rows and 5 columns. And then I am creating 100, 100 mean, 100 minimum, 100 maximum, 100 variance, 100 median for the SBP value for each of the 100 data, and invoke the mat11 by plugging all of them and finally getting the output. Are you seeing this is the values? This is the values. Take a look at that. 1, 2, 3, 4, 5. And you understand why 5? Because 5 columns. And 1, 2, 3, 100. Because length is length n3. N3 is a list. It has a list. It has how many data? 100 data. Okay. So now all of this is the this is the average, this is the minimum, this is the maximum, this is the variance, this is the median of SPP. Just these lines of code you can apply to the American data, which has 50 states data. You split the data by states and compute all of these things. If you have the world data from the World Bank for the 200 countries, you split the data by countries and find their everything. So important, okay? If someone of you will ask me, I hate looping, I don't like loop. Is there any way I can do it without looping? This is your questions? Yes. There is also a way how to do this without using looping. If you do 2, 3 looping, it will be slower. Okay. So they have found that looping 2, 3 looping will be slower. They have done this. Okay. How to put the column names and everything is mentioned in there. Now it will be more beautiful. If I put the name and finally if I write here M head M, this is the way I put. mat11 was the output. I put the call names of mat11 as a mean SBP, minimum SBP, maximum SBP, variance SBP, median SBP, and finally got the output. Okay. So this is what we did. If I write it, if I want to add a age variable there, then this is the age variable. Then if you take a look at the mat data, that is the mat data. Okay. That is the mat. Okay. Now I want to tell you how can we do the same thing without using looping. In order to do this without using looping, N3 is my data, is L apply. L apply means least apply. Okay. N3 is what? N3 is what? Least. It has how many data? 100 data. I am doing without loop. Without loop, this is the thing I'm doing. Unlist. Okay, it has a list, but I'm doing unlist. I'll apply on the list on this function of X. Now I want to find mean S dot matrix X because this is a function of X. Then I'm finding its mean, and then minimum S dot matrix X, and then DBP, and then S dot matrix X DBP. and all data frame combined average minimum. I just took the three, and then finally, like I got this way. The results is this. Are you seeing each age is coming corresponding average minimum maximum age 9.2 average maximum minimum average maximum minimum and met values is coming like that way. Okay. Give me just 2 minutes. Let me drink some water. Now, from N2 matrix, this is the head N2, right? From there, in question number 89, I want to take 10 rows and 10 columns. So take a look at that N4 equal to 10 rows and 10 columns. Take a look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rows and 10 columns, right? Now I want to do double loop. I take value 1 to 10, that means it goes by the row, and J goes 1 to 10, it goes by the column. So there is 10 rows and 10 columns. How many entries? 100 entries, right? How to run double loop? That is what. I want to find the grand mean. Grand mean, that means overall average of this 800 and subtract from each of these. So take a look at that. This one is called, I am finding the mean as dot matrix N4. It has become, if I just run like this way, see, it will become, now it is a data frame. It is a data frame. If I just run these things, it has become a matrix now. And as dot numeric, when you run and if you do this, you are getting mean of these GM. This is the mean of these numbers. Okay, mean of this number. Now what I want to do, NA 10 row and 10 column, a null matrix has been created and I'm invoking these null matrix inside the loop. Okay, this is the null matrix, like empty bowl I have given you, then I am putting milk and then cereal and then serve you. Okay, so I'm creating empty bowl. Mat means empty. Nothing is available there, but all is NA. If you run like this way, okay, let me run it. Though want to show you physically how it looks like. MAT is everything NA. Nothing is in there. Okay, nothing is in there. But when I invoke it on this place, see, I'm invoke it in here. IJ double loop. So that means I am invoking it in here and putting every one is in there. What is one? One is this. Each time I take and then I subtract it. But before N4, N4, N5 also has a Z. So see how looping is done, double looping is done. Okay. So if you run like this way, then the results that you are saying what I am doing, I am taking 8 and subtract 14.193 from 8 and then plugging and getting this number. Okay. So for example, I am going to take 2, okay, and subtract these 43.91 and getting this result like this 41.91. So that means in a situation when you have a data matrix you have to go by each element by row and column, use double loop, and then if you need to subtract, add or square, and have to run some kind of arithmetic operations. So that means arithmetic operations means addition, subtraction, multiplication, division. These are called arithmetic operations. Logarithm is not arithmetic operation. Exponentiation is not linear operator or linear operations or arithmetic operations. Okay. So like the trigonometric functions, they are not arithmetic. Okay. Understand, right, what I'm saying? So after this code, you have learned how to run double loop, okay, in a data to compute something. Okay. Now question number 91 is telling you, okay, what is longitudinal data? Longitudinal data is this type of data. Longitudinal data means if there is a person I, this is the first, second, third, fourth, but ID, this is the ID is same. Suppose 1, 1, 1, and then 2, 2, 2, right? So now what I want to do, this is known as the long format data. Long format data. This is known as the long format data. This long format data, I want to make it as a wide format data. I want to put just ID there, 1, ID 2, and then I want to put here SBP, first measurement, SBP, second measurement, SBP, third measurement. Okay, this is the way it could be gone. Okay, it could be gone. This is the way. This is what called the wide format. So now if you have a longitudinal data that is long format, how can you make it in wide format? If you have a long format, you want to make it in a wide format, okay? That could be done by using this. Let me show you by running this. Let me show you, this is my head D1. This is the head D1 data, okay? And now with all of these things running there, now this is the data. Take a look at that head. D10 is the data. Okay. SBP, BZIT, and DBP. Okay. Now I want to do these things and do like this way. Take a look at that. Oh, head W1. This is called the wide format data. Now see, this person is appearing only one time, right? This is his SBP in the first visit, second visit, third, fourth, fifth, sixth, seven, 8, 9, 10. Okay. So what I did in here, white format decast. This is coming from tidy art package. D10 was my data. ID by visit value. I just want to take the SBP and I have put all of their 10 values in there. In that way, white data long data become white data. Just for the two variables in here. Okay, in order to transfer it back, you understand, right? Data is this format. I want to make it like that format. It could be done. Now I am showing you just the SBP variable. Then it will come DBP. Then like other variables if you want. And in that case, it will be just only one person. Okay. It is only one person. And this is, if you select these things, then this is like the first visit data. First visit SBP. Okay, and then fast BP visit DBP, then fast BP visit triglyceride. So that is the way you can Sometimes you need this type of data in order to do some kind of research. Actually, when I took my bioinformatics class, I did this type of things. Wide format, long format data, I have to transfer it to the wide format data in order to do some different samples pairwise t-test to check how many of them are falsely rejected, but those should not be rejected, something like this. Anyway, this is the way you can, but if I want that one to come back to the long format data again like this, and then if you see now it is again long format, head, long one, this is the long format data again. The same ID number, are you seeing ID is same? This is the ID, this time one like this. So this is the ID, this is his first visit, this is the different ID first visit, different ID first visit, okay? ID number is different. So what you learn in here, if you have a long format data, how to transfer it to the wide format data, okay? And in this case, suppose you have a data, this is the data, and then this data does not have any missing value. So now if you take a look at this data, dimension of D11, it does not have any missing values, okay? Dimension of D11 does not have any missing values. So in this data, let me tell you why these things come to my mind. You have a data, and in that data, you have given directly original data to her, and I purposely enter some missing value, 10% missing value, and give the missing value data to her. These 2%. Okay. And I ask them, and then these persons, I give the complete data, both of these data. Okay. 3%, I gave her without missing data, I gave her with missing data, and I gave her both of these data. I want to see they do some statistical analysis. Okay. And finally, when they submit the result to me, I want to check whether both of them did what correctly. Understand? So I purposefully want to enter 10% missing values in these data. Now see NA dot omit D11. This is the original D11 data. In the D1 data, all the missing value has been omitted. Now I want to purposefully enter their 10% of those data points are missing. In order to do that, I have to install a package. And then immediately library, then summary I want to see, and after summary I want to enter their missing values. Now take a look at the summary. Previous summary does not have any missing value. Are you seeing D11? Now it has missing values, right? So what I did, I entered 10% missing values. So what you learn in here, sometimes artificially you want to add some missing values noise in the data and see how you analyze people who are as a data scientist or people who are claiming themselves as a good analyst. So how can they perform with their work? Okay. So complete data and missing data, how to enter the missing data in here. And sometimes, suppose you are doing work, research and everything, and someone said that, well, you did all of this work very good, but suppose in your data there are some missing values. How can you handle those things? Then the original data, you enter some missing values and do the sensitivity analysis. Sensitivity analysis means how the results perform when there is no missing values, how the results performs there is a 10% missing values, how the results looks like when there is a 15% missing values. Okay. Whenever data is generated, people are coming, people supposed to come, but they are not coming, right? So that means is his third visit, we do not have any data. So what should we put there? Missing, right? Okay. After this, so this is how can we combine data? Suppose she brought one data from 200 students, she brought another 300 data from another student. How can we combine them? If these are different students, we can combine one below the other, right? You go to the 100 students, she went to the different 100 student. She went to the 100 student in Ocean from campus, okay? Like the campus in the Gulfport, okay? And you are in the Hattiesburg campus, okay? You took 100 students and then she took 100 students. How can I combine? So it should be one go below the other. Okay, all other variable is the same, okay? But you went to the same student, she went to the same student. You took the measurement of temperature and then you took the blood pressure, okay? And you took the height, weight, okay? But she took the blood test and she took the like the triglyceride, cholesterol, sugar level, A1C, all of these things. But both students have unique identity, right? Same students. So I can mark them by row. Okay, so one data is merging by row by matching the ID. Another is putting one below the other. If ID is different, one below the other. If ID is the same, merging by the ID. This is what now I'm going to discuss. So this is the one data is taking that has a ID, age, SBP and DBP variable. Okay, so this is one data and that is another data taking ID, TC, TG, height and weight. So I can merge them by ID variable. This is the options I can merge them. Okay, so two data has been merged in here. Okay, two data has been merged in here, but this is the row merging. Okay, this is a row merging. Okay, there is also C bind and R bind. You will see there is a R code C bind means column bind. Okay, there is also a R code R bind that means row bind by row. Okay, and there is also merge. We can merge like this way. Now, question number 97 is telling them I can merge them by column, ignoring the C5. So that means I merge M1 and M2 by column, ignoring C5. C5 means ID variable is appearing twice. I want to exclude one. That is the C5 means. Okay. This could be done by also inner join, left join. This is coming from the SQL code. SQL. SQL means SQL. Okay. Sequential query language, SQL. Let me see. Sequential query language. I knew. Why did I forget? Because I did not practice for the last 5 years. SQL meaning. Sequential query languages, structure query language, structure query languages. So these inner join are coming from the SQL language. The people also called it SQL. It is actually originally started from SQL, but they have a name with the name of the French, I think ER company, something like that. Then they change it to SQL. Originally, it is a SQL name. Okay. Anyway, so these are the same thing. Left join, inner join, and left join. These are the code directly coming from the SQL. Okay. So, and then now I want to do how to do the row binding. Row binding could be done. Suppose I took a random sample of size D2 and D3 and then I merge them. After merging them, if I want to do the, I have taken a sample subset D2 and D3 and this is another one. And finally, if I want to do the R merging, this is called the, I am binding them by row. Okay. So finally, that one is binding by the row. Okay. These are the all like data analysis, data mining, and data visualization problem. I think I have shown you around 10 data visualizations, how to visualize your data. Watch this video, read this document again and again, and things will be easier for you. Okay. So now let me stop the video in here. We will start discussing now your stop recording.